Ready to dive deep into the world of rare earth elements with us.
Yeah, let's unearth some of the mysteries surrounding these essential elements.
We'll dig through research articles, scientific papers, all that good stuff to bring you the fascinating truth about rare earth elements.
By the end of this, you'll be able to drop some serious knowledge in any conversation about tech or geopolitics.
All right, let's jump right in. You know, it's funny, even their name rare earth is a bit misleading.
It is, isn't it? It's one of those things that sounds like it should be straightforward, but it's actually quite complex.
Like, are they actually rare or not? What's the deal?
Well, the truth is, they're not as rare as their name suggests. Take cerium, for example.
Cerium, okay.
It's more abundant in the Earth's crust than copper.
Really? No way. I mean, copper, that's everywhere. We use it for everything.
It's true, but here's the thing.
Okay.
It's not just about how much of an element exists. It's about how accessible it is, how it's distributed, and the economics of getting it out.
So even if there's tons of it, if it's spread out like glitter in a hurricane, it's not going to be very useful.
Exactly. It's like trying to bake a cake with ingredients that are scattered to the wind.
You technically have everything.
You have it all, but actually gathering and using it is a whole other challenge. And that's where the real story of rare earth elements begins. To understand them, we need to take a trip back in time.
Oh, taking a history detour. I'm always up for a good origin story. Where are we going?
To a small village in Sweden that had a surprisingly big impact on the world, Ytterby.
Ytterby? Never heard of it. Sounds quaint.
Mm-hmm.
What's this tiny Swedish village got to do with high tech?
It's remarkable, really. Ytterby is where scientists discovered a whole bunch of elements, all huddled together in a small area, all with very similar properties, caused quite a stir in the scientific community.
Oh, wow. A real chemistry mystery then. How many elements are we talking?
We're talking yttrium, ytterbium, terbium, and erbium, all named after this one village.
Wow, that is a mouthful of elements. And you said they all have similar properties. That sounds like a nightmare to separate and identify.
It was, and still is. It all comes down to understanding a bit about atomic structure, specifically something called lanthanide contraction.
Lanthanide contraction. Okay, you've officially lost me.
Think of it like this. You start lining up these rare earth elements, and each one, as you go down the list, adds another electron to a very specific part of the atom.
Makes sense, adding more stuff.
Right. But here's where it gets strange. Instead of the atom getting bigger with each added electron, it actually shrinks a bit.
Hold on, adding more makes it smaller. That feels, I don't know, counterintuitive. How does that even work?
It's true. And this lanthanide contraction, as it's called, has a huge impact on how these elements behave chemically, why they're so similar, and why those scientists had such a hard time teasing them apart back in the day.
So we've got these 17 elements, all with their quarks thanks to lanthanide contraction, all hanging out together in the Earth's crust, making them a real pain to separate. Where do we even begin to look for these things?
Well, you can think of it like a geological treasure hunt, really, spanning a diverse range of formations. Some are found in alkaline magmas, for example.
Okay.
And then there are laterite deposits, particularly rich in heavy, rare earth elements, which have their own fascinating story.
Light versus heavy rare earth elements.
Yeah.
Okay, I have a feeling that distinction is going to be important.
It is. And it all goes back to the Earth's formation, you see, and those geological processes that have been unfolding over billions of years.
Okay, so the Earth has been doing its thing for billions of years, forming mountains, oceans, all that. What does that have to do with rare earth elements being light or heavy?
Well, those terms, light and heavy, they're not just random labels. They actually tell us a lot about where we can find these elements and why some are more abundant than others.
All right, break it down for me.
Imagine the Earth's early days. Superheated molten rock, everything churning and swirling.
Like a cosmic soup.
Exactly. And just like in a soup, some ingredients mix in easily, while others tend to separate.
So those light rare earths, they were the ones eager to mingle.
You got it. They're not as dense, so they didn't mind hanging out in the Earth's molten magma, mixing with all sorts of other elements.
And as that magma cooled and solidified, those light rare earths just ended up, what, randomly scattered throughout?
In a way, yes. They were more likely to escape that dense early Earth and become part of the Earth's crust as we know it today.
So easier to find, easier to access.
Yeah.
Makes sense. What about the heavier ones? They must have been the party poopers clinging to the bottom of the soup bowl.
Something like that. Those heavy, rare earths, they were denser, more comfortable hanging out with the heavier elements in the Earth's mantle.
The mantle. That's deep down, right? Not exactly a convenient location if we're talking about mining.
It's true. The heavy rare earths needed some serious geological action to reach the surface. We're talking millions of years of tectonic plate movement, volcanic eruptions, things like that.
Wow. So those heavy rare earths, they're like the survivors of a geological obstacle course. No wonder they're harder to get our hands on.
Exactly. And that brings us to another interesting point about those heavy rare earth elements. Remember those laterite deposits I mentioned earlier?
Yeah.
Well, they're formed through a very specific weathering process, usually in tropical climates, and they tend to concentrate those heavy rare earths. Southern China, for example, they've got some seriously large laterite deposits.
Okay, so the Earth's history is basically written in these elements, light and heavy. But why does all of this matter in the grand scheme of things? Why should we care where these elements hang out?
Well, it's not just about geological curiosity. It all comes down to supply and demand.
Because we need these elements for so much of our technology.
Exactly. They may be hidden away in rocks, but they play a vital role in our modern lives. We've talked about how rare earth elements aren't so rare in terms of their overall abundance on Earth, but their uneven distribution and the complexities of extracting them make them incredibly valuable. They're essential components in so much of the tech we use every day. Smartphones, electric cars, renewable energy systems, the list goes on.
It's like they're the unsung heroes of the tech revolution hiding in plain sight.
Exactly. And the demand for them is only going to increase as we become more reliant on technology and move towards a more sustainable future.
Which makes those heavy rare earth elements, the ones that had to go through the geological ringer, even more important.
Precisely. Take neodymium, for example. It's a heavy rare earth element, and it's absolutely essential for making the powerful, compact magnets used in everything from smartphones and laptops to electric vehicles and wind turbines.
Okay, so magnets. I get it. Magnets are cool. But where do they fit into all this high-tech stuff? What makes them so special?
Neodymium magnets, they're not your average fridge magnets. They are incredibly strong for their size, which is why they're used in so many applications. For example, those tiny speakers in your phone. They need those powerful neodymium magnets to function. And the motor of an electric car, forget about it. It wouldn't be possible without neodymium magnets. They make the motor smaller, more efficient, and more powerful.
Wow, so neodymium is like the secret sauce in so much of our tech.
Absolutely. And that brings us to another important aspect of rare earth elements, geopolitics. We've talked about how China has some of the largest reserves of rare earth elements, especially those heavy ones, and that's led to some interesting dynamics on the global stage.
The China question. It seems like everyone's talking about it these days. What's the big deal?
Well, when one country controls a significant portion of the world's supply of a resource that's critical for everything from consumer electronics to national defense, it raises some eyebrows.
So it's not just about the tech itself, it's about who controls the supply chain.
It's about security, economics, global influence. It's a complex issue with no easy answers. And it highlights the importance of finding alternative sources of rare earth elements and developing new ways to recycle and reuse what we've already extracted.
So it's not just about digging more stuff out of the ground, it's about finding a more sustainable way forward.
Exactly. We need to be smart about how we use these resources. And that's where recycling comes into play.
Okay, recycling. Everyone's doing it these days, so what's so special about recycling rare earth elements? Can't we just toss our old phones in the bin and call it a day?
I wish it were that easy.
Yeah.
Remember that we talked about how rare earth elements are scattered throughout the Earth's crust? Well, the same problem applies to recycling them.
So it's back to that scattered element problem. We spent all this effort getting them out of our gadgets in the first place.
Yeah, it's not as simple as just melting down old phones and picking out the rare earths. We're talking about tiny amounts of different elements, all mixed up with other metals and materials.
Okay, so how do we solve this? Are we stuck in this loop of needing more rare earths, but not being able to easily recycle what we've already used?
It's a challenge for sure, but there's a lot of really interesting research and development happening right now in the field of rare earth recycling.
So there's hope. Tell me more about what's being done.
Scientists and engineers are coming up with some incredibly innovative ways to extract those valuable rare earth elements from e-waste. We're talking about things like bioleaching, which uses, get this, bacteria.
Bacteria. To recycle our phones? Now that's thinking outside the box.
It might sound strange, but certain types of bacteria are actually really good at separating metals from other materials. They basically eat the unwanted stuff, leaving the valuable rare earths behind.
Wow, nature to the rescue. What else is in the works?
There's also something called solvent extraction, which is like a high-tech separation process. It uses special liquids to selectively extract different rare earth elements from the mix. And then there are new advancements in magnetic separation techniques, taking advantage of those unique magnetic properties we were talking about earlier.
So many different approaches. It sounds like there's a lot of potential for making rare earth recycling more efficient and cost-effective.
Exactly. But like any new technology, it takes time, investment, and importantly, collaboration to scale up these solutions. We need everyone on board, from researchers and engineers to policymakers and businesses.
It's a team effort, for sure. But let's be honest, right now, how much are we actually recycling?
It's still early days. Currently, only a tiny fraction of rare earth elements are actually being recycled.
A tiny fraction.
Think less than 1%.
Wow, that's not very encouraging.
No, it's not where it needs to be. But that also means there's a huge amount of room for improvement. And the potential benefits, they're enormous, both for the environment and for the economy.
Okay, so less doom and gloom, more action and innovation. If we can crack the code on rare earth recycling, we could lessen our dependence on mining, reduce the environmental impact, and maybe even take some of the heat out of those geopolitical tensions we discussed.
Exactly. It's about moving towards a more circular economy for rare earth elements.
So instead of this linear mine, use, dispose model, we create a closed loop. We extract the elements, use them, and then recycle them back into the system.
Precisely. It's a more sustainable, responsible way to utilize these critical resources. It's not just about the technology itself, it's about creating a more ethical and resilient supply chain.
Well said. It seems like rare earth elements are this microcosm of the challenges and opportunities we're facing in the 21st century.
They really are. They're a powerful reminder that innovation isn't just about creating new things, but about finding better ways to use what we already have. It's about thinking long-term, collaborating across borders, and ensuring that these essential resources are available for generations to come.
It's been fascinating to dig into this with you, to peel back the layers of complexity and really understand the significance of these elements. From their unusual atomic structure and hidden origins deep within the Earth to their role in shaping the future of technology and the global balance of power, rare earth elements have proven to be anything but boring.
Agreed. And hopefully this deep dive has given everyone listening a newfound appreciation for these elements and the crucial role they play in our lives.
And that's a wrap on this deep dive into the captivating world of rare earth elements. We hope you've enjoyed this journey into the heart of modern technology, geopolitics, and the quest for a more sustainable future. Until next time, keep asking questions, stay curious, and remember, sometimes the smallest things can have the biggest impact.